T minus 1 minute. T minus 50 seconds. T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good morning to our fellow future engineers and also to our co-STIers soon. Finally, we are now on the last day of our week-long activity. The end is almost near, but learnings will never end since it's a continuous process. We will forever learn not just in school but also in life, which is the most important. But today, let us share to you again some additional knowledge about some of the topics tackled in the field of engineering, prepared only for you by our lecturers for today. To start with, let us first discuss the topic entitled Heating, Ventilation, and Air Conditioning, or famously known as HVAC, from the Mechanical Engineering program.
Hi everyone, I'm Christian Sioxenia, a third-year mechanical engineering student here at STI Negros University. Today, we'll discuss about air conditioning and ventilation systems. According to William Carrier, air conditioning, it is refers to the control of temperature, moisture content, cleanliness, air quality, and air circulation as required by occupants, a process or a product in the space. We have ASHRAE. It is refers to the American Society of Heating, Refrigeration, and Air Conditioning Engineers Incorporated. They publish 4 volumes and standards. First, fundamentals. Second, HVAC system and equipment. Then refrigeration, and last is the HVAC applications. We have the common units and dimensions. We have the gallons per minute for liquid volume flow rates, the cubic feet per minute for air volume flow rates, inches water gauge for pressure measurement in airflow systems, and ton with 12,000 BTU per hour for description of cooling capacity or rate, ton hour, 12,000 BTU for cooling energy. Heating in space conditioning is performed to either A is to bring a space up to a higher temperature, or B is to replace the energy being lost to colder surroundings by a space so that a desired temperature range may be maintained. We have the figure of the flow of energy in space heating. We have the given equation, the rate of sensible heat transfer equals to the mass flow rate times the constant pressure times the temperature in the exit minus the temperature in the inlet. It is also equals to the volume flow rate times the constant pressure over the specific volume times temperature in the exit minus temperature in the inlet. For the example, determine the rate at which heat must be added in BTU per hour to a 3,000 cubic feet per minute airstream passing through a heating coil to change its temperature from 70 to 120 Fahrenheit. Assume an inlet air specific volume of 13.5 feet cube per pound mass and a specific heat of 0.24 BTU per pound mass Fahrenheit. So for the solution, the heat being added is sensible, as it is contributing to the temperature change of the airstream. equation 1-2 applies. Our formula is the rate of sensible heat transfer equals to volume flow rate times the constant pressure over specific volume times temperature in the exit minus temperature in the inlet. To substitute the given value, we have 3000 feet cube per minute times 0.24 BTU per pound mass Fahrenheit, that is our constant pressure. And for the temperature exit minus temperature inlet, we have 120 minus 70 Fahrenheit and 60 minutes per hour. And for the specific volume is 13.5 feet cube per pound mass. So our rate of sensible heat transfer is 160,000 BTU per hour. Cooling. This is the transfer of energy from a space or from air supplied to a space to make up for the energy being gained by that space. It may be for comfort or occupants or provision of suitable environment for manufacturing, process control, or storage. In figure 1-5, this is the flow of energy in space cooling. We have the air handler with coils in series. Also, air handler with coils in parallel. For the comfort requirements, we have temperature, humidity, air movement, fresh air, clean air, noise levels, lighting, and furniture and work surface. For comfortable environment, it is broader than just temperature and humidity. Comfort requirements that are typically impacted by the HVAC system include dry bulb temperature, humidity, air movement, fresh air, cleanliness of the air, and noise levels. Some HVAC systems address these comfort requirements better than others. We have the HVAC systems, and the 5 system loops are airside, chilled water, refrigeration, heat rejection, and controls. The purpose of this period is to provide a method for understanding the components of different types of HVAC systems. The premise of this method is that any HVAC system can be dissected into basic subsystems. These subsystems will be referred to as loops. There are 5 primary loops that can be described virtually any type of HVAC system. We have airside loop, the chilled water loop, refrigeration loop, heat rejection loop, and controls loop. Before we continue, keep in mind these 3 observations. First, while these 5 loops can be used to describe virtually any HVAC system, not every system uses all 5 loops. Second, the temperatures used in this period are representative of conditions found in typical HVAC system, but will differ from application to application. And third, while another loop could be added for heating and humidifying the space in some systems, this clinic focuses primarily on comfort, cooling, not heating. This is the example of the airside loop. We have the supply air, sensible heat, the moisture or the latent heat, and the return air. Most HVAC systems used today deliver conditioned, heated, cooled, humidified, or dehumidified air to the conditioned space to add or remove sensible heat and moisture. So, example is to imagine the conditioned supply air as a sponge. In the cooling mode, as it is refers a space in the sponge or supply air absorbs sensible heat and moisture. The amount of sensible heat and moisture absorbed depends on the temperature and humidity as well as the quantity of the supply air. We have the cooling load components. order to determine how much supply air is needed for a given space and how cold and dry it must be, it necessary to determine the rate of which sensible heat and moisture or latent heat enter or are generated within the conditioned space. And Figure 6 shows typical sources of heat and moisture, which are commonly called cooling loads. Conduction heat gain from outdoors through the roof, exterior walls, and glass windows or skylights. Solar radiation, heat gain through glass windows or skylights. Conduction heat gain through the ceiling. We have the internal heat and moisture generated by people. And we have also heat gain from air infiltrating into the space from outdoors. In addition to those depicted on this figure, other common sources of heat and moisture includes heat gain from outdoor and heat generated by the fans and motors in the system. We have the supply fan and filter. Component of the airside loop is a supply fan that delivers the supply air to the space. In the example in figure 7, air is supplied to the conditioned space to maintain a desired temperature of 75 degrees Fahrenheit. Another one of the comfort requirements is to provide an adequate amount of fresh outdoor air to the space. In this example, the required amount of outdoor air for ventilation is brought into the building and mixed with the recirculated portion of the return air. The remaining return air, that which has been replaced by outdoor air, is exhausted as exhaust air from the building, often by an exhaust or relief fan. In this example, outdoor air at 95 degrees Fahrenheit dry bulb mixes with circulated return air at 75 degrees Fahrenheit dry bulb. So the resulting temperature of the mixed air is 80 degrees Fahrenheit dry bulb. However, the air also must be filtered in a typical HVAC system. The mixed air process through a filter to remove many of the airborne contaminants. Another component is cooling coil. As mentioned earlier, during the cooling mode, the supply air must be cold enough to absorb excess sensible heat from the space and dry enough to absorb excess moisture. A heat exchanger, commonly known as cooling coil, is often used to cool and dehumidify the supply air before it is delivered to the space. Another component is chilled water cooling coil. In figure 9 shows an example of cooling coil that has chilled water flowing through it. As the warm, humid mixed air passes through the coil, it comes into contact with the cold tubes and fins. In many HVAC systems also use the airside loop for heating and humidification. Often, a heating coil or humidifier is located near the cooling coil in the same airside loop. We have the part load operation, the constant volume system or CVS. The supply air quantity is the constant and supply air temperature is variable. Finally, the supply air is delivered to the conditioned space. The temperature and humidity of the supply air, however, are only applicable for one point in time. A constant volume system provides us constant quantity of supply air and varies the supply air temperature in response to the changing cooling load in the space. Another part load operation is variable air volume or VAV system. In this system, the supply air quantity is now variable and the supply air temperature is constant. A variable air volume system varies the quantity of constant temperature supply air in response to the changing cooling load in the space. In this system, a VAV terminal unit is added to the airside loop. Each conditioned space or group of similar spaces, called a zone, has a separate VAV terminal unit that varies the quantity of supply air delivered to that space or zone. We have the fan coil unit. We have supply air outlet, cooling coil, supply fan, return air inlet, and a filter. A fan coil unit is a simple example of the airside loop. In figure 12 shows an example of a fan coil unit that would be installed in the conditioned space. Return air from the space is drawn into the unit at the base and can be mixed with outdoor air that enters through a separate damper in the back of the unit. We have the central air handler. In the central air handler, we have cooling coil, supply fan, filters, supply air outlet, return air dampers, and outdoor air dampers. Another example of the airside loop is a central air handling system. A central air handler is typically installed outside of the conditioned space, possibly on the roof or on a dedicated mechanical room. We have also supply air distribution system. In this system, we have diffuser, flexible duct, sheet metal supply duct, VAV terminal, central air handler, return air inlet, and outdoor air inlet. A supply air distribution system, typically constructed of sheet metal ducts, fittings, and diffusers, is used to direct the supply air from the central air handler to one or more conditional spaces. The example airside loop in Figure 14 includes a central air handler and ductwork to deliver supply air to multiple VAB terminal units. Diffusers are used to distribute the supply air effectively to the conditioned space. Proper air diffusion is an important comfort consideration, especially in VAV systems, to avoid dumping cold supply air on the occupants of the space. Sealing plenum return. In Figure 15, air returns from the conditioned space to the central air handler through an open sealing plenum. The plenum is the space between the ceiling and the roof or floor above. Alternatively, a separate return air duct system could be used to direct the return air back to the air handler. So, that's all for today. Thank you and goodbye.
Okay, so I think you have learned again something today. Let's do not waste time and proceed to our next topic. And it is all about vibration engineering. Let's
Hi everyone, I'm Christian Sioksanya, third year mechanical engineering student here at STI was Negros University. Today we will discuss about vibration engineering. Today we will discuss the brief history of vibration, examination of vibration's important role, vibration analysis of an engineering system, definitions and concepts of vibration, and the concept of harmonic analysis for general periodic motions. In the origins of vibration, in 582 to 507 BC, Pythagoras, the Greek philosopher and mathematician, is the first to investigate musical sounds on a scientific basis, and further he developed the concept of pitch. Around 350 BC, Aristotle wrote treatises on music and sound. In 320 BC, Aristoxenos wrote a three-volume work entitled Elements of Harmony in 300 BC. Euclid wrote a treatise Introduction to Harmonics. AD 132, Zhang Heng invented the world's first seismograph to measure earthquakes. Galileo Turelli. Galileo is the founder of modern experimental science. He started experimenting on simple pendulum and published a book, Discourses Concerning Two New Sciences in 1638. Robert Hooke, 1635 to 1703, he found the relation between pitch and frequency of vibration of a string. Joseph Saussure, 1653 to 1716, coined the word acoustics for the science of sound. He founded the nodes, lobes, harmonics, and the fundamental frequency, and also calculated the frequency of a stretched string from the measured sag of its middle point. Sir Isaac Newton, 1642 to 1727, published his monumental work, Philosophia Naturalis Principia Mathematica, in 1686, discovering three laws of motion. Joseph Lagrange, 1736 to 1813, he found the analytical solution of the vibrating string and the wave equation. Simeon Poisson, 1781 to 1840, solved the problem of vibration of a rectangular flexible membrane. R.F.A. Cleaves, 1833 to 1872, studied the vibration of a circular membrane. Lord Baron Rayleigh founded the Rayleigh-Ritz method, used to find frequency of vibration of a conservative system and multiple natural frequencies. In the recent contributions, 1902, Fram investigated the importance of torsional vibration study in the design of propeller shafts of steamships. Aurel Stodola, 1859 to 1943, he contributed to the study of vibration of beams, plates, and membranes. Also developed a method for analyzing vibrating beams which is applicable to turbine blades. C.G.P. de Laval, 1845 to 1913. He presented a practical solution to the problem of vibration of an unbalanced rotating disc. 1892, Lyapunov laid the foundations of modern stability theory, which is applicable to all types of dynamical systems. 1920, Duffling and van der Pol wrote the first definition solutions into the theory of nonlinear vibrations and drew attention to its importance in engineering. Introduction of the correlation function by Taylor. In 1950, advent of high-speed digital computers and generate approximate solutions. 1950s developed finite element method enabled engineers to conduct numerically detailed vibration analysis of complex mechanical, vehicular, and structural systems. Need to study vibration. First is vibrations can lead to excessive deflections and failure on the machines and structures. Second is to reduce vibration through proper design of machines and their mountings, and to utilize profitably in several consumer and industrial applications to improve the efficiency of certain machining, casting, forging, and welding processes. And last, to stimulate earthquakes for geological research and conduct studies in design of nuclear reactors. So in the basic concepts of vibrations, we have vibration: any motion that repeats itself after an interval of time. Vibration system consists of spring or elasticity, mass or inertia, and damper. involves transfers of potential energy to kinetic energy and vice versa. Degree of freedom is the minimum number of independent coordinates required to determine completely the positions of all parts of a system at any instant of time. Example of single degree of freedom system is shown below in figure A. We have the slider crank spring mechanism. Example of single degree of freedom system is another is spring mass system and the torsional system. For the example of 2 degree of freedom system, we have shown below in the figure A, B, and C. And for the 3 degree of freedom systems, and for the example of infinite number of degrees of freedom system, the figure is shown below. Infinite number of degrees of freedom system are termed continuous or distributed systems. Finite number of degrees of freedom are termed discrete or lumped parameter systems. More accurate results obtained by increasing number of degrees of freedom. In the classification of vibration, we have first, free vibration. It is a system is left to vibrate on its own after an initial disturbance and no external force acts on the system. Example, the simple pendulum. Second is forced vibration. A system that is subjected to a repeating external force. Example is the oscillation arises from diesel engines. Resonance occurs when the frequency of the external force coincides with one of the natural frequencies of the system. And then we have undamped vibration, when no energy is lost or dissipated in friction or other resistance during oscillations. Damped vibration, when any energy is lost or dissipated in friction or other resistance during oscillations. Linear vibration, when all basic components of vibratory system, example, the spring, the mass, and the damper behave linearly. We have also nonlinear vibration. If any of the components behave non-linearly. Deterministic vibration, if the value of magnitude of the excitation or force or motion acting on a vibratory system is known at any given time. Non-deterministic or random vibration, when the value of excitation at a given time cannot be predicted. Here are some examples of deterministic and random excitation. In figure A, we have a deterministic or periodic excitation. In figure B, we have a random excitation. So, these some steps or tips in vibration analysis procedure. And some example of the modeling of forging hammer. And we have an example of mathematical model of a motorcycle. And figure 1.18 shows a motorcycle with a rider. Develop sequence of 3 mathematical models of the system for investigating vibration and the vertical direction. Consider the elasticity of tires, elasticity and damping of the struts in the vertical direction, masses of the wheels, and elasticity, damping, and mass of the rider. For the solution, we start with the simplest model and refine it gradually. When the equivalent values of the mass, stiffness, and damping of the system are used, we obtain single degree of freedom model. In this model, the equivalent stiffness, or K equivalent, includes the stiffness of the tires, struts, and rider. The equivalent damping constant, or constant equivalent, includes the damping of the struts and the rider. The equivalent mass includes the mass of the wheels, vehicle, body, and the rider. So in figure B and C, we have the mass equivalent, K equivalent, and constant equivalent. In figure C, so in this model can be refined by representing the masses of wheels, elasticity of tires, and elasticity and damping of the struts separately. As shown in figure 1.18c, in this model, the mass of the vehicle body, or MV, and the mass of the rider, or MR, are shown as a single mass, MV plus MR. When the elasticity as spring constant, KR, and damping as damping constant, CR, of the rider are considered, the refined model shown in figure 1.18d can be obtained. So the subscripts are T equals to tire, V is vehicle, W is wheel, R is rider, S is strut, EQ is to equivalent. So note that the models shown in figures 1.18b to d are not unique. For example, by combining the spring constants of both tires, the masses of both wheels, and the spring and damping constant of both struts as single quantities, the model shown in figure 1.18e can be obtained instead of figure 1.18c. So, that's all for today's discussion. Thank you and goodbye.
Thank you, our second lecture for this morning. Now we are down to the last but not the least topic we have in this immersion program, and I think it is the most important, especially in every engineering student. We have the how to prepare for the engineering board exam.
Good day, everyone. I am Gloridan Sigovieta, a second-year electrical engineering student, and today we are going to discuss about how to prepare for the electrical engineering board exam. So we are going to tackle some tips on how to prepare for the board exam, and we are also going to tackle on what are the things to avoid while preparing for the exam. So let's start. So after our graduation, we have one goal, and that is to become a licensed engineer. And enable for us to become a licensed engineer, we have first to pass the licensure examination. So what are licensure examinations? Licensure tests are typically offered by the government organization for the purpose of regulating a specific profession or occupation. So it is a set of tests to be allowed to work in a particular area or profession. So we have the Professional Regulation Commission. So this is usually referred as the PRC. So the PRC is a three-man commission attached to Department of Labor and Employment. Its mandate is to regulate and supervise the practice of the professionals who contribute the highly skilled manpower of the country. So the question is, how can I prepare for the board exam? So let us share some tips on how you can prepare for the upcoming board exams. Okay, so first of all, it is very important to set your vision, your mission, and your goal. So what are these three? Your vision is the maximum horizon that you can imagine. Your mission are the specific tasks and the important jobs that you must do. And your goal is your destination or what you need to accomplish. So it's very important to set these three things first and able for you to prepare yourself for the exams. Second, plan to put in the time. So mastering the material you need to know for the boards will take some time leading up to the board exam. So before registering for your exam, do your best to allocate study hours over a large period of time. Next, learn on how to manage your time. So we have here the time quadrant. So you must divide or you must categorize the things that you must do into these 4 quadrants. We have the urgent, not urgent, important, and not important matters. So learn how to prioritize urgent and important matter first. Next is to find a good study environment. So study somewhere that is far or away from distractions as possible. If you are reviewing your notes or better yet testing yourself in front of a TV, chances are you won't be very productive. So you must find a quiet corner in your local library that you can rely on for you to focus on your study session. Next, it is also important to discover your learning style. So the methods that others used won't necessarily be as effective for you. So you must ask yourself, are you a visual or an auditory learner? Finding out which style works best for you is something to consider in the early stages of preparing for the board exams. If you are a visual learner, for example, you can try videos. If you are an auditory learner, you can record lectures and play them back. Adaptive learning works especially well for those looking for a dynamic experience that is based on learning theory and science. Next is to make good use of mobile resources to study. So there are numerous apps that can give you the tools to create your own flashcards or exams. So instead of using your mobile gadgets to scroll on your social media accounts, use it to research some review materials. Then, study textbooks or review materials thoroughly. So ensure that you are well versed with all the topics and concepts of the coverage of the exam. Also, do not ignore diagrams, tables, or graphs. You can also start a study group. So preparing for the board exams with your friend is a great way to address each other's weaknesses. So you may have one area completely covered to the point where you can be the teacher in that group, and you can also struggle immensely in some other area. So try to have everyone agree on a set time to meet. Your discussions will go a long way. So the next tip is to remember important formulas, notes, and dates. So remembering certain important formulas, notes, and dates is required in almost all subjects. So you can write down these points on flashcards that can be easily carried so that you can conveniently familiarize them from time to time. Then, avoid burnout. So the last thing you want is to be burned out studying. It can be extremely beneficial to take study breaks. So research suggests that doing something you enjoy the day before the exam has a more positive effect than continuing to study up to the last minute. Next is to take care of your health and do some exercise. So according to a study reviewed by Harvard Health, those who exercise with moderate intensity 30 minutes per day every day have improved memory and concentration. So if you feel as though you're in a fog, start exercising regularly. Also, drink adequate amount of water and meals. Then the next one is to get enough sleep. A study shows that irregular sleep directly affects academic performance. So aim for at least 7 hours of uninterrupted sleep so that you can focus more during your study sessions. Lastly, test yourself. So testing yourself may just be the best way to study for the boards. As we've noted, studying by reading over your materials and not testing yourself may just be the biggest mistake you can make in preparing for the exam. So one effective method of assessing your knowledge is to practice exams, which stimulate the of the actual board exam you're taking. So those are some tips that we can share and able for you to prepare for the board exam.
Morning everyone. Today we're going to discuss about what are the things that we should avoid while preparing for board exams. First, studying continuously for long hours. With the board exams, nearing students start studying continuously for 5 to 6 hours. Students believe that studying at a stretch will improve their concentration, but this is a misconception. In fact, what happens is just the opposite. When you study continuously, your mind stops working after a while, and eventually you are not able to concentrate. Therefore, it is suggested to take a few breaks. Study for at least 8 to 12 hours daily, but make sure you make gaps in between. Second, too much independence on teachers. There are many students who assume that they will score well in the exam as long as they attend the review sessions conducted by the teachers and study lessons from the guides teachers provide them. The guide given by the teacher is a great source to get an idea about the things that is important to know for the examination. It can be of great help during the preparation, but attending the review sessions and simply going through the study guide will not guarantee great results. If you want to score well in the exam, you should take responsibility to ensure that you truly understand the material. Third, no early preparation. There are many students who start studying only when few weeks are left for exams. This is strictly a no-no. Preparing for board exams often takes more time than you think, so it is better to get started early. One of the biggest advantages of starting early is you will be left with enough time for revision. With early preparation, you don't have to get nervous at the last moment thinking that how much will you score. Will you be able to complete the paper on time, etc. Fourth, last-minute mugging up. Often, it has been noticed that students leave a few points of things for the last minute. Students think they will go through few notes just before they enter the examination hall. They believe that doing so will reinforce things in their mind. However, this is a wrong mindset. Mugging up during the last minute leads to a lot of confusions while writing the exam. That confusion can be avoided if you don't leave anything for the last minute. Fifth, studying without a plan. One of the common mistakes students commit is they will start studying without knowing what are their priorities. Which field they want to choose after class X? What are the fields they should focus on in that study session? If a student does not know what grades he or she needs to earn for a successful career, which study material should be referred, or how to study efficiently, chances are there that he or she will be unprepared for the exam. Don't forget, develop positive attitude. Always feel positive and believe in yourself. Positive attitude does reflect on your personality and helps you face the situation easily. It will also increase your problem-solving confidence and prepare you to deal with exams. Pray. Always give thanks and ask for guidance from our Almighty. Prayers are powerful. All our dreams can come true if we have the courage to pursue them. That's all, and thank you.
In every learning that you can gain. But here in STI West Negros University, we do not just offer knowledge but also fun, fostering growth physically, mentally, and spiritually, and to build camaraderie between each and every one of us. To show to you, let me share this presentation showing how engineering student before the pandemic. Okay, so thank you very much to our lecturers for today. So to give his speech, let's all hear the voice of the current governor of the College of Engineering, no other than future engineer Christian Oksenia.
Hi everyone, kamusta man ng 5 days immersion? I hope nga nakahatag kami idea about sa mga specific topic or subject nga makuha naton sa mga engineering courses, especially nagid sa mechanical engineering, electrical engineering, and civil engineering subjects. I hope nga nadugangan ang inyong interest nga magpa-enroll sa engineering courses kag diri sa STI Negros University. So, see you next school year everyone. I hope nga magkita ay kita sa STI kag sa engineering department. Subong pa lang nga daan, gina-welcome na gid kamo namon as part of our engineering family. So, thank you and God bless everyone.
Thank you very much, future engineer Oksenia. Okay, so at this juncture, we would like to thank our participants for your active participation in our activity. Also to the teachers for allowing us to share our inputs to your students. We hope to see you soon, students, in STI West Negros University and choose the College of Engineering. Thank you once again and good day.